Assalamualaikum. We are from Group 7. Today we are going to present our case, fats, oil and grease from restaurant entering the sewerage system. So this is our team members, Aina Zafira, Aina Farhana, Shamsina Shasha, Adini Rania, and Muhammad Danish. For case overview, fats, oil and grease are actually the leftovers from cooking and food preparation that are frequently found in the kitchens and restaurants. They are originating from dairy products, vegetable oils and also animal fats. Historically, vegetable oils were utilized for cooking and lamp lighting, while animal fats were employed for cosmetics, medicine, and food. These ingredients then continued to be the essential in cooking throughout the Middle Ages and were also used as the
Conclusion:
lubricants
fats, oil,
in the
and grease
manufacture
from
of
restaurant.
candles. The improper disposal of fats, oil and grease can have so many bad impacts to the environment. The disposal of untreated sewage that contain all these three things from the blocked sewage can seep into the ground, then contaminating the groundwater supplies. The contaminated groundwater then can affect for those who rely for drinking and irrigation, especially for the communities that lives around there. The overflowing sewage also can spread onto the land, then contaminating soil. This can impact the health and quality of plants by reducing the soil fertility and also reduce the agricultural productivity. Last but not least, improper disposal also can contribute to the climate change. For the example, degradation of fats, oil and grease will result in the production of methane, which is the greenhouse gases. This can worsen climate change by contribute to the global warming.
Okay, Assalamualaikum. Now we're going to the next subtopic, which is the sampling method. So the first one is grab sampling. So how to prepare this is we need to use clean bottles and wear gloves. So before we start the sampling, we need to identify the sampling point, which is where is the wastewater escapes the grease trap and enters the sewer. So that's the sampling point for the sampling method. And then we need to collect the samples. So how we collect is the sample we collect during the peak hours, and we only take one single sample collected at one specific time. And then storage, how we need to seal the bottle after we take the sample. We need to seal the bottle and label the date, time and location, and then we need to quickly send it to the lab, and if it requires to refrigerate, we need to refrigerate. And then for the lab analysis, we'll just test the samples, fat, oils and grease levels. Okay, moving on to the next sampling method, which is the composite sampling. So how to prepare is we use same several bottles, and this time we need large container for mixing, and then also wear gloves. And then we also need to identify the sampling point, which is where the wastewater escapes the grease trap and enters the sewer. So how to collect the samples is for this sampling method, composite sampling, we need to sample every hour during peak hours. So multiple samples will be tested and combined. And then the storage, we after we get all the sample, we pour all the collected samples into a large container that we have just now and mix it well. And then seal the mixed sample in a bottle and label it same with date, time, and location. And also we're gonna send the sample to the lab to test the composite sample of the FOG levels, which are the fats, oils, and grease levels. So, what are the differences between the two sampling methods that I've presented just now, which is the grab sampling and the composite sampling? So, both of them have advantages and disadvantages. So, basically, the grab sampling is just single sample, instantaneous sample, very just in specific moment. It's very simple, very quick, very minimal, um, and so on. But as for the composite sampling, it requires a multiple samples combined over time. It's more complex, more time consuming, needs more equipment, which is the large container, uh, and yeah. So that's the differences between the two types of sampling method.
Next is the extraction method. This extraction method, more likely known as a technique that being used to separate and desired substance from mixture by selectively transfer them from one place to another. Here, extraction method by using soil matrix or that written by Bruce E. Richer that call extraction of hydrocarbon contamination from soil using accelerated solvent extraction. From this article, they're using an analytical technique of extraction method by using gas chromatography. From the procedure, firstly, they u- firstly for the sample preparation they using a dry and wet soil. Next, extraction process using a solvent such as DCM, hexane, heptane, or mixture with acetone. In condition, the temperature between 1 to 5 to 200 Celsius and the pressure is 1500 psi. Next, for post-extraction, by adding 10 milliliter of solvent to extract for the paste separation, which they're using a dry solvent with sodium sulfate and clean up with silica gel column. And the sample was using to concentrate extract by turbo vac 2 and analyze it with gas chromatography. For the result, the accelerated solvent extraction ASE with DCM acetone at the temperature 175 Celsius is effective for extracting hydrocarbon from soil and offer faster extraction and lower solvent consumption compared to traditional methods. Next, extraction method by using a water matrix or water sample from the from the article called liquid extraction for the removal of fat, oil, and grease for restaurant wastewater that written by R.W. Research. From this article, they're using an analytical technique of extraction method called liquid extraction, called and also known as LLE. From the procedure, first from the procedure, firstly they're using a sample preparation, which is wastewater sample are collected and may be pre-treated to remove large particulates that can interfere with extraction. Second, addition of organic solvent, which immisci- immiscible organic solvent like hexane, dichloromethane, or chloroform is added to the aqueous wastewater sample. Next, mixing and emulsification, which is the mixture of vigorous shaking or stir to promote the transfer of FOG from the aqueous phase to organic phase. Next, phase separation, which is the mixture is allowed to settle in a separatory funnel where, gravity causes the denser aqueous phase and the less dense organic phase to separate it. And lastly, for solvent evaporation and analysis of FOG, organic solvent is evaporated and residue can be weighed for gravimetry analysis or further analyzed using techniques like gas chromatography (GC) to determine the specific component and concentration of FOG. Analytical instrumentation. The analysis of fats, oils, and grease (FOG) from restaurants, effluents entering the sewerage system involve several analytical techniques such as gravimetric methods, infrared spectroscopy, gas chromatography, high-performance liquid chromatography, and others to ensure compliance with environmental regulations and to prevent blockage in the sewer system. The suitable analytical instruments for analyzing the contaminant for this case is gas chromatography (GC) with flame ionization detector (FID). So there are three instruments for this analytical instrumentation is gas chromatograph, columns, flame ionization detector (FID) or mass spectrometer (MS). So there are five steps procedure for this analytical instrumentation. The first one is extract FOG using an appropriate solvent. The next step is derivative the sample if necessary. The next step is inject the sample into a gas chromatograph. The fourth one is separate the components using a suitable column. And the last step is detect and quantify the components using a flame ionization detector or mass spectrometer. Comparison of different instruments. There's a lot of instruments, but I will explain only three different instruments. The GCFID stands for gas chromatography with flame ionization detector. HPLC stands for high performance liquid chromatography, and FTIR stands for Fourier transform infrared spectroscopy. The recovery rates for GCFID is high recovery rates, it especially with proper sample extraction and preparation. Separation efficiency is quite excellent and is capable of separating complex mixture into individual components. The sensitivity is high and it can detect low concentration of FOG. Suitability for complex matrix is very good, especially with appropriate sample preparation. And other consideration is requires derivation for certain non-volatile components. The next one is HPLC. HPLC is stand for high performance liquid chromatography. So the recovery rates is high, but it can vary depending on the nature of the stationary phase and mobile phase. The separation efficiency is good, though not as high as GC for volatile components. The sensitivity is high, especially with UV vis or fluorescence detection. And for the suitability for complex matrices is excellent, and it can handle non-volatile and thermally unstable components. And the other consideration is requires careful selection of columns and mobile faces for optical separation. So the last one for FTIR is Fourier transform infrared spectroscopy. The recovery rates is depends on the extraction method, and it typically good if proper technique are used. And the separation efficiency is low as it provide bulk characterization rather than separation of individual components. And the sensitivity is moderate and it best for identifying functional groups rather than quantification. And the suitability for complex matrices is limited and it can struggle with highly complex mixture. And the other consideration is it quick and non-destructive and it best for functional group identification. So the conclusion is
Each method has a strength and is chosen based on the specific requirements of the analysis, such as the need for detail, component separation, sensitivity, or simplicity.
The conclusion: fat, oil and grease from restaurant entering the sewerage system is a significant problem with negative effect for both plumbing and the environment. Here, the conclusion. Firstly, sewage blockage. FOG harden as it cools, causing clogs and pipes. This can lead to sewage backup in homes and business, causing expensive repair and potential heart hazard. Secondly, environmental damage. FOG can escape treatment plants and pollute waterways. It harms aquatic life by reducing oxygen level and smoothing habitats. Lastly, treatment costs. FOG make wastewater treatment more difficult and expensive. Therefore, proper FOG management by restaurants through grease traps and responsible disposal of used cooking oil is crucial to protect our infrastructure and environment.